So this is another question from IIT JEE PYQ from the chapter Newton laws of motion. So here is the question. Two blocks of mass 2.9 kg and 1.9 kg are suspended from a rigid spot S by the two inextensible wires, each of length 1 meter. So here the length of each of the wire is 1 meter. And the upper wire has negligible mass and the lower wire, the upper wire is here is of negligible mass, that means mass of the wire is nearly equal to 0, that means 0. And the lower wire is having a mass density of 0.2 kg per meter. That means mass of the lower wire is what? Mass of lower wire is equal to 0.2 into length of the wire, that is 1 meter, that is equal to 0.2 kg. Okay. The whole system of the blocks, wire and support have an upward acceleration of 0.2 meter per second square. Okay, so here the whole system is having an acceleration of 0.2 meter per second square in the upward direction. Here acceleration due to gravity we have to take 9.8 meter per second square. We have to find out the tension at the midpoint of the lower wire. Okay, so I will draw the for first case, like for first part, I will draw the diagram here. This is the case here. This is the block of mass 2.9 kg, and this is the wire of length 1 meter, and this is another block of mass 1.9 kg, and we have to find out the tension at this point. Okay, so this length will be 0.5 meter and this length will also be 0.5 meter. So we have to find out what will be the tension in the middle point of this lower wire. Yeah. So if I draw the free body diagram of this lower part only, then the mass of this lower part will be equal to what? Mass of the half of this wire. The mass of full string was 0.2 kg, so half of the wire will be equal to 0.1 kg. Okay. So mass of this lower part, that means mass of lower part, I will write here, mass of lower part that will be equal to let us suppose I am denoting it with m1, okay, or ml with the lower part. So ml is equal to what? 1.9 kg plus half of the mass of this wire, that is equal to 0.1. So this total mass is equal to 2 kg. Okay. So if I draw the free body diagram of this 2 kg mass, let us suppose this is our 2 kg mass now. Combinedly I am taking, this is the 2 kg, and there will be some tension acting at this point. Okay. And there will be the weight of this 2 kg mass in the downward direction, that will be equal to 2 multiply 9.8. And the acceleration of this body in upward direction, that is given as 0.2 meter per second square. 0.2 meter per second square. Okay. So if I write the equation of motion for this body, then upward force T minus downward force, that is equal to 2 into 9.8 is equal to mass into acceleration of this body, that is equal to 2 multiply acceleration is 0.2 meter per second square. So here tension in the string we are getting 2, I will take common, into 9.8 plus 0.2, that will be equal to 2 multiply 10, that is equal to 20 Newton. Okay. So here tension in the string is 20 Newton. Okay, that is at the midpoint of the lower wire. Now coming to the second part here, our second part, what is it asking? Find the tension at the midpoint of the upper wire. So here upper wire is of negligible mass, so tension at every point will be equal to the same value. tension in the upper wire at every point will be having the same value. Let us suppose it is T. Okay, so if I will draw here a diagram again. Like this is our rigid spot here, and this is the upper wire. This is a mass m1, and let us suppose this is another mass. Then the mass of the bodies were 2.9 kg, and this was 1.9 kg. Okay, and mass of this wire was 0.2 kg, that we had find it here, 0.2 kg. Okay, so mass of this lower wire was 0.2 kg. Okay, so now if I draw this free body diagram of this lower mass combinedly, if I take, then this total mass will be equal to 2.9 plus 0.2 plus this 1.9. That will be what? 2 and 3, 4.9, 4.8 plus 0.2, that will be equal to 5. Okay, so it will be net mass will be equal to 5 kg. So if I draw the free body diagram of this 5 kg, then there will be some tension force in this string that will be pulling it upward in upward direction. Okay, and there will be a net weight acting in the downward direction due to the gravitational pull of the earth, that is equal to what? 5 into 9.8. Here G we have to take 9.8, and this whole system is moving in upward direction with an acceleration of 0.2 meter per second square. Okay, so if I write the equation of motion here again, then upward force is T minus the downward force is 5 into 9.8 is equal to 5 into acceleration of this body in the upward direction, that is equal to 0.2 meter per second square. So tension at this point will be equal to what? 5 multiply 9.8 plus 0.2. So here tension will be equal to 5 multiply 10, that is equal to 50 Newton. Okay, so here tension at the midpoint of the upper wire, that will be equal to 50 Newton. Since tension in the upper wire is constant at every point, so we have find it here or at midpoint or at any point, tension will be equal to 50 Newton only. Okay.